In this lesson, we're going to start our discovery of the operators in C++. We're going to begin with the assignment and arithmetic operators, but we'll also take a look at the logical operators, relational operators, streaming operators. But for now, just the assignment and arithmetic. That's going to be quite enough. So, what are operators to begin with? They are the built-in functions that allow you to manipulate and to modify the values that you are dealing with in your program, quantities that you're storing in variables. So, what are some of the operators? Addition, subtraction, those are arithmetic operators. The less than is insertion, greater than, extraction, and there are logical operators and etc. So let's begin by looking at assignment. Okay, we use the equal sign for assignment. We have 4 examples here. You've seen these before in declarations. We have int Bob equals 5, so we're assigning 5 to the memory location named Bob as an initial value. In the second example here, we have an assignment, typical assignment. Tax is equal to income times rate. If we take rate to be declared as a const, as indicated by the uppercase alpha characters, then here in the third example, this would be illegal. Rate is assigned 0.05. No, compiler will not allow that because you're trying to modify a constant. So declared as a constant, we assume. And in the fourth example, I have 4 is equal to income plus 64. Well, I'm trying to assign to the left-hand side a value that is not 4. I can't modify 4. I can't change 4. The compiler won't let me change a constant literal. So, what are the steps that the compiler goes through when executing an assignment statement? Well, what it needs to do first is to find out what is the value on the right-hand side. And in fact, every assignment statement is of the form left-hand side is assigned right-hand side. So it's going to determine what is the value of the right-hand side. It then needs to determine what's the type of the right-hand side, what's the type of the left-hand side, and what does it need to do to actually make that assignment. So in this case, it determines what's the value on the right-hand side. It does that by looking up the values of income and rate. It sees that both of these are of type float. Now, as it turns out, we'll see this here in a few minutes, that a float times a float is a float. In fact, if we combine them in any ways, add them, subtract them, divide them, a float times a float divided by a float plus a float minus a float is going to be a float. So what's on the right-hand side is a float. Okay? Then it's going to determine what's on the left-hand side. Well, if tax has been declared as a float, then the assignment of a float to a float is okay. The compiler has no problem with that. In fact, if the type declaration of what's on the left-hand side is such that no information is lost when the assignment is made, then the compiler will make the assignment. For instance, if tax has been declared as a double, well, assigning a float to a double is okay because no information is going to be lost. Precision has been increased rather than decreased. If, on the other hand, tax was declared as, say, a short or an integer, then information is going to be lost. The decimal part has to be dropped off. If you do this, the compiler will give you a warning, and that, as far as we're concerned, is just as bad as an error. You should not allow that to happen. Now, sometimes that's what you want to do, and you can force that to happen by telling the compiler that is what you want to do, and you do that with a static cast. Let's take a look at casting. So suppose that some value has been declared as an int, num1 and 2 declared as doubles. So in this assignment statement here, I'm going to assign to some value, which is an int, num1 plus num2. Num1 plus num2 is a double because they're both individually double. So I'm assigning a double to an int. Double has a decimal part, ints don't. So if I'm going to just let the compiler do that, it's going to give me a warning, an error. How do we force it? How do we tell the compiler that's what we want? We do what is called a static cast. This is the syntax. It's static underscore cast, and then in angle brackets the type we want to cast that to. Now it must be made very clear that when you do this, you are not changing the nature of the declarations of what you are trying to cast. In other words, num1 and num2 remain of type double. But for this assignment, and for this right-hand side, that quantity is going to turn into an int. In other words, the decimal part is just discarded. It's truncated off. It's not rounded, it's truncated off. And then the assignment is made. Okay, let's take a look at the arithmetic operators. They are, of course, plus, minus, times, divide, and the percent sign, which stands for modular arithmetic, and we'll discuss that here in a minute. Okay, type promotion. As I say, when you combine two or more variables of different types, the compiler has to know what type to give that. So let's take a look. If I combine, and it doesn't really matter whether it's addition, subtraction, multiplication, or division, or even modding. If I combine, say in addition, a float and an integer, then the compiler is going to promote that to a float. What it can do is it can change the integer value to a float and add two floats and give a float. But again, you must understand that the declared type of integer 1 will remain int. It does not change its declaration to float. It only changes its value temporarily in this calculation to a float. And the result is a float. So a float minus an integer is a float. A float times an integer is a float, etc. What about a float mod integer, or an integer mod float? That's not allowed, of course. You can only use modular arithmetic with two integers. So if I combine a character and integer, that'll be promoted to an integer. Yes, you can multiply a character times an integer. Can I multiply an integer times a float? Yes. A float times a double, that gives you a double. An integer times a double gives you a double. A character times a float gives you a float, etc. As long as no information is lost, the compiler will do an automatic promotion. So let's take a look at some examples here. Suppose that Celsius is declared as a float and Fahrenheit is declared as an int. If I have Celsius, which is a float, being assigned 5 over 9 times Fahrenheit minus 32. It seems that this is a perfectly good assignment statement. The problem is that 5 is stored as an int. 9 is stored as an int. What's an int divided by an int? It's an int. And how many times does 9 go into 5? 5 divided by 9 is 0. 9 goes into 5 0 times. It's an integer. This is a common mistake. What this means is that Celsius will always be 0 in this case. Doesn't matter what Fahrenheit is. How do we fix this problem? Well, if we're going to use constant literals, one easy way to fix it is to write it as 5.0, which is a float, over an int, and that gives you a float because it gets promoted to float. And then everything works out just fine. We could also have used 5 over 9.0. We could also have used 5.0 over 9.0. Any way you want to do that, that's fine. As a second example, suppose I have declared as a float average age, and as an int total of ages and num people. Now here I want to make the point that the type of these variables is very important. Okay, num people is an int. We don't have any partial people. Total of ages. Well, ages are usually thought of as whole numbers, so the total of ages would be a whole number. So those two variables should be declared as an int and should remain as integer types. On the other hand, I want to think of the average age as a float. We can say, well, the average age of the group is 26.8. So how do I make an assignment if I say average age is equal to total ages over num people? Well, this, remember, is an integer. This is an integer. And an int divided by an int is an int. I'm not going to get the floating point value that I want. So how do I make that happen the way it really should happen? Well, what I'm going to do is I'm going to static cast the quantity total of ages. Now, it's really important to understand that I've cast only the numerator. If I cast the whole expression, the total of ages over num people, I end up with what? Well, total of ages over num people is an int over an int is an int. And I lose all the information. If I then cast the entire expression, then I've done nothing. So I want to cast either the numerator or the denominator, or both individually, but not the quotient. I will still lose the information. Okay, let's take a look at modular arithmetic. What you need to remember about modular arithmetic is this, that A mod B is the remainder after integer division of A by B. Okay? So, for example, 4 mod 7, what is it? Well, ask yourself, how many times does 7 go into 4? 0 times. But what's the remainder? The remainder is 4. How many times does 3 go into 7? It goes twice, right? You get 6. But what's the remainder? It's 1. So 7 mod 3 is 1. 27 mod 3 is what? Well, 3 goes into 27 exactly 9 times, and the remainder is 0. So 27 mod 3 is 0. Now, why is this useful? Well, you're going to find it to be useful in many, many situations. Here's a particular example. Suppose that you read a value in from a user. Let's just call it X. Okay, now you don't know what it is. It could be 16,285. You don't know at the time. But suppose that you need to pick out of that, say, the tens digit and assign it to something. Well, I tell you what, let's call X A, B, C, D, E. Those are the digits, okay? So this is the units. This is the tens. This is the hundreds, thousands, and 10,000s. I want to pick off D, the tens digit. What is that? How do I know what it is? Well, one way to do that is I'm going to take X and I'm going to mod it by 100. X mod by 100. What is that? Well, how many times does 100 go into X? It goes ABC times. Or in other words, look at a numerical example. How many times does 100 go into 16,285? It goes in 162 times. What's the remainder? The remainder is DE. The remainder is 85. Now, D is what I'm after. That's what I'm trying to isolate. So if I take then X mod 100, that's DE, and then divide it by 10. Well, that's DE divided by 10. Well, how many times does 10 go into DE? It goes D times. So, using integer division and modular arithmetic, I've isolated the tens digit. There's actually two ways that you can do that. I'm going to take X and I'm going to divide it by 10. That gives me A, B, C, D, and then I'm going to mod that by 10. That will also give me D. And you can write up expressions for the units digit, the hundreds digit, the thousands digit, etc. Okay, let's take a look at the increment and decrement operators. These are very interesting. Val++ and plus plus val. The operator is plus plus. This is a post increment. This is a pre-increment. Likewise with the decrements, the negative negative. There's post and pre. So val plus plus, semicolon, a statement all on its own, and plus plus val are in essence the same, and they are equivalent to val equal to val plus 1. In other words, val plus plus or plus plus val increments the value of that variable val. Why do we have it? It's fast. That's why. I have to say that if this operation occurs once, twice, or even 1,000 times, it's better to write it in this format because it's easier to understand. The compiler finds the value of val, adds 1 to it, and then assigns it to val. Anybody can read that and understand that's what's going on. They may not understand what val plus plus is. However, if this operation is going to happen 1 billion times, say in a loop, then it's much better to use that expression val plus plus because it is much, much faster in the run time. Likewise with the decrement, val minus minus and minus minus val. Now, what's the difference between the post and the pre? Well, that you can't tell until you put it inside of another or a bigger expression. So let's take a look. The difference between a pre-increment and a post-increment is this. That with a pre-increment, it is the first thing that's done in the complete statement. And a post-increment, it is the last thing that is done in a complete statement. So if we look at these two examples, val and num are integers. Val has a value of 6. Then I'm going to make the assignment. Num is assigned plus plus val. So what's the value of num and what's the value of val after this is executed? Well, in this case, the first thing that happened is that val gets incremented. Okay, so val, it started out as 6, it's now 7. Num, it gets assigned 7. So after the execution of this statement, the values of both num and val are 7. Let's go to the other example here. Okay, val starts out as 6. Okay, num has no meaningful value. Now, in the assignment, the increment happens last, so the assignment happens first. Num is given the value of val. It's assigned 6. Then val gets incremented. So you see there is a big difference. Okay, the other fast operators. These are what they call self-assigning. X plus equals y, x minus equals y, divide equal y, times equals y, mod equal y. Just looking at one of them, the top one, x plus equals y is equivalent to x is assigned x plus y. So if, for instance, you wanted to increment something by 3, then x plus equals 3 is the same as x is assigned x plus 3. Okay? And again, the usefulness of these is that they are very, very fast. And that is a wrap-up of the arithmetic and assignment operators.